All right, let's dive in. Today, we're talking about something called predicate logic. And look, if you've ever thought that simple true-false logic just doesn't cut it for the real world, you are absolutely right. What we're about to cover is a massive upgrade to your logical toolkit. And this isn't just some abstract idea. This is the language that's running under the hood of everything from complex databases to the AI that's changing our world.
So think about this for a second. How on earth does a computer actually understand a sentence like this? I mean, what does it do with a word like every? Our basic run-of-the-mill logic, the simple true or false stuff, it completely chokes on words like every, some, or all. It just wasn't designed for that level of complexity.
And that right there is the heart of the problem. That basic system, which has a fancy name, propositional logic, it's fine for simple things like the light is green. True. But the second you introduce a variable, like every computer, the whole thing just falls apart. It can't handle it. So clearly we need something better. We need that upgrade. So this upgrade we're talking about, it really comes in two key parts. The first piece of the puzzle is something I like to call a statement machine. Now, its proper name is a predicate.
So, what is a predicate? Honestly, the best way to think about it is as an incomplete sentence. It's a statement with a placeholder, a blank space, just waiting for you to drop a value in. And the moment you do, bam, the whole thing snaps into focus and becomes either 100% true or 100% false. No in between.
Yeah, let's call it a truth template. That's a great way to put it. For example, let's create a predicate called P of X, and P of X is just the statement X is greater than 3. Right now, as it sits, that statement is neither true nor false, right? It's just a template waiting for us to give X a value.
Okay, so let's put our template to work. Let's feed it some numbers and see what happens. If we plug in the number 4 for X, we get 4 is greater than 3. Well, that's obviously true. Now, what if we plug in 2? We get 2 is greater than 3, which is, of course, false. See? It's that simple. The template takes an input and it spits out a definite true or false answer every time. And what's really cool is that this isn't just for one variable. Our little truth template can have as many blank spaces as we need. We can have predicates with 2 variables, 3, you name it. For example, we could define a new one, Q of X and Y, as the statement X equals Y plus 3. And it works the exact same way. We just have to fill in both blanks to get our answer. So if we say X is 3 and Y is 0, the statement becomes 3 equals 0 plus 3. That's true. But if we try X equals 1 and Y equals 2, we get 1 equals 2 plus 3. And yeah, that's definitely false. It's a really simple idea, but it's incredibly powerful.
Okay, so we've got our statement machine, our predicate. That's only part one of our upgrade. Now we need to answer a really important question. How often is our statement true? Is it true for every possible value we could plug in, or is it just true for some of them? To answer that, we need our second tool, quantifiers.
So in the world of quantifiers, there are really two big players. First, you've got the universal quantifier. It looks like an upside-down A, and it means for all or for every. A good way to think of it is like a scanner, checking every single item in a set to make sure the rule applies. Then you've got the existential quantifier, the backward E. This one means there exists or for some. This is less of a scanner and more like a searchlight. It's just looking for at least one case where the statement is true. Now, here's something that is absolutely critical. Before we can use these quantifiers, we have to define our playing field. It's called the domain of discourse. Basically, it's the universe of things we're allowed to talk about. Are we talking about all numbers? Or maybe just positive integers? Or every computer on a specific network? You have to define this, because without that context, a logical statement is totally meaningless. And to see just how important this domain is, let me ask you a question. Is this statement true? X squared is greater than or equal to X. I mean, think about it for a second. At first glance, it kind of seems like it should be true, right? Okay, so using the new logical language we just learned, here's how we'd write that question. We'd use the universal quantifier for all X, and then our predicate is X squared greater than or equal to X. So, is it true? Well, here's the kicker. The answer completely depends on the domain. If our domain, our playing field, is all integers, whole numbers, like -2, -1, 0, 1, 2, then yes, the statement is true. Go ahead, try to find an integer that breaks the rule. You can't. But what if we change the domain to all real numbers? That means we now include fractions and decimals. All of a sudden, the statement becomes false.
Why? Because we can find just one counterexample, x equals 0.5. See, 0.5 squared is 0.25, and that is not greater than 0.5. The domain, the context, changed absolutely everything.
Okay, so we have our statement machines, the predicates, and we have our quantifiers that tell us all or some. Now, let's combine them. This is where things get really powerful, and we can start building some truly complex ideas using what's called nested logic.
A nested quantifier is exactly what it sounds like. It's when you have one quantifier inside the scope of another one. And listen, if you take one thing away from this, let it be this. The order of those quantifiers is everything. It is critically important. You swap the order and you can completely change the meaning of what you're saying.
Let's start with a really simple, obvious idea from math class. For any two numbers you can possibly pick, let's call them x and y, there will always exist some other number, z, that's their sum. Right? I mean, it's just addition. 2 plus 3 is 5. 10 plus 20 is 30. This rule always holds true.
So how do we write that using our new logical tools? Just like this. For all x and for all y, there exists some z where x plus y equals z. It's a really clean, elegant way to express a fundamental truth about how addition works. And of course, this statement is absolutely true.
Okay, but let's see what happens if we get a little sloppy. What if we just take that there exists a z part and we move it to the very beginning of the sentence? What does that do?
Let's translate our new, reordered statement back into plain English. It's now saying this: there exists some single magic number z, such that for all possible numbers x and y, their sum is always that same z.
I mean, that's just ridiculous, right? There's obviously no single magic number that is the answer to every addition problem in existence. By making one tiny change, just swapping the order of our quantifiers, we went from a universal truth to something completely false. See? The order is everything.
Okay, let's do one final example to bring this all home. Here's a simple rule you definitely learned in math class. It's a fact about how numbers work. So the question is, how can we use predicate logic to state this rule with absolute perfect mathematical precision?
Boom, there it is. That one single line of logic says everything we need it to, perfectly. Let's walk through it. It says, for any number x and any number y, if x is greater than 0 and y is less than 0, then their product, x times y, has to be less than 0. See how all the pieces fit? The quantifiers, the predicates, the logical operators, they all come together to express that rule with zero ambiguity. That's the power you now have.
So there you have it, a quick tour of predicate logic. We've gone way beyond simple true or false. You now have the fundamental tools to describe really complex ideas and relationships with total precision. So I'll leave you with this question. What complex truths out there, maybe in your job, in a coding project, or just in how you think about the world, can you now state with perfect clarity?